Hey there, and welcome. Every single data science project, whether you're trying to predict stock prices or figure out what customers want, it all starts with the same basic questions about the data itself. So today, we're going to walk through that journey, step by step, from just a bunch of raw files all the way to these powerful, super organized databases.
Okay, so here's the game plan. This is basically our roadmap for today, and we're going to follow the exact path a data scientist would. First, we've got to figure out what our data even is. Then, how do we get our hands on it? After that, where do we put it? And finally, we hit the big one. What happens when there's just too much data? This is the core workflow, really, for any data project you'll ever touch.
First things first, before you write even one line of code or start dreaming up some fancy model, you got to stop and look at your data. You have to ask a really simple question. What am I actually dealing with here? At this image, this just lays it out perfectly. This is the first big choice you have to make. Is your data structured? All neat and tidy in rows and columns, like that table on the right? Or is it unstructured, kind of like that jumble of text on the left? Or it could be images, audio files, you name it.
So here's the bottom line. Structured data is predictable. It follows a strict set of rules, a fixed schema, which makes it super easy to search and analyze, right? If you want to know your total sales, you just add up the price column. Simple. That predictability is gold for businesses. Unstructured data, though, that's the Wild West. It's freeform, it's messy, but it holds a ton of juicy information. You just have to work a little harder to get the secrets out of it.
And honestly, that's a huge chunk of what a data scientist does all day. You're a chaos wrangler. You take all this messy, unstructured stuff, think customer reviews, social media posts, you name it, and you find clever ways to pull out the important bits, organize them, and put them into a nice, clean table that a computer can actually make sense of.
Okay, so you've figured out what kind of data you're looking for. Now what? Well, the next logical step is, how do you actually get it? How do you pull it from wherever it lives and bring it into your project? A lot of the time, maybe most of the time, your journey is going to start with a simple file. And the king of all files is the CSV, the comma-separated values file. It's basically just a spreadsheet in plain text. It's incredibly simple, everyone can use it, and it's a fantastic place to start.
Now, this is what's so cool about this slide. Look at the power and honestly the simplicity of the tools we have today. With a library in Python called Pandas, loading a whole data set from one of those CSV files, it's literally just one line of code. That's it. It's never been easier to just get started.
But, not all data fits into a neat little flat table. What if you have something more complex, with layers? Like, imagine a customer record that also has a list of all their past orders nested inside it. For that, you've got JSON. It uses these key value pairs, which is just perfect for organizing that kind of complex, hierarchical data.
And here's the beautiful part. The tools are consistent. That same Pandas library that just ate up your CSV file, it can handle JSON just as easily. It's smart enough to look at that nested structure and automatically flatten it out into a table you can actually work with. It does all that heavy lifting for you, which is amazing. Okay, but files like CSVs and JSON, they're static, right? They're a snapshot in time. What if you need data that's alive, constantly updating? Think stock prices or a Twitter feed. That's when you have to move beyond files and start using APIs, application programming interfaces.
And this is the absolute best way to think about it. An API is like a messenger. You don't get the entire library delivered to your house. You just send a messenger, that's your API request, with a little note asking for a very specific book. The messenger runs off, finds it, and brings back just that one book. It's an unbelievably efficient way to get exactly the data you need right at the moment you need it.
So, you've got the data. Awesome. But what happens when your project grows? Having hundreds, maybe thousands of CSV or JSON files scattered all over your computer, it becomes a total nightmare. And that brings us to a much more organized, scalable, and powerful solution for storing it all: databases.
And look at that. Just like our very first decision, structured versus unstructured data, choosing a database brings up a very similar choice. Do you need the rigid, predictable organization of a relational database, like the table on the left? Or do you need the flexibility of a non-relational or NoSQL database, which, hey, looks a lot like those JSON files we were just talking about, doesn't it?
This really just boils down to picking the right tool for the job. Relational databases, think of them as very strict librarians. Everything has its place, everything follows the rules. This is critical for things like financial records, where you need that data to be perfect. NoSQL databases, on the other hand, are more like a flexible workshop. They're perfect for data that's changing all the time, like a social media feed, where every post can be a little different. Here, speed and adaptability are more important than rigid rules.
And when you're actually talking to a relational database, it's a very logical step-by-step dance. First, you connect to it. Then you create what's called a cursor. It's basically just a little pointer that lets you execute commands. Third, you execute your command, using SQL. And finally, you commit your changes, which saves them permanently. It's a really reliable and standardized process.
All right, now we get to a challenge that I promise you every single data scientist runs into eventually. It doesn't matter what kind of data you have or where you're storing it. Sooner or later, you hit the problem of scale. Just think about it for a second. Your laptop. Maybe it has 16 gigs of RAM. But what happens when someone hands you a single data file that's 50 gigabytes? Well, if you try to load all of that into memory at once, your computer's just going to give up. Your program will crash. So, how in the world do you handle this data deluge?
The solution is actually super elegant and totally essential. You don't try to drink the entire ocean in one gulp. For files, you use a technique called chunking, just like you see here. You tell your program, hey, don't read the whole file at once. Just read it in smaller pieces, maybe 10,000 rows at a time. You process one chunk, throw it away, process the next, and so on. You never overwhelm your computer's memory.
And here's the brilliant part. Databases are built for this exact problem. When you ask a database for data, it doesn't just dump the entire thing on you at once. It gives you back that cursor we mentioned earlier, and that cursor is like a smart bookmark that points to your data. It only fetches the results as you ask for them, maybe one by one or in small batches. It's a just-in-time delivery system, which is incredibly efficient with memory because the system only does the work when you absolutely need it.
And that really ties everything together, doesn't it? When you understand these core ideas, the shape of your data, where it's coming from, and its size, you can build a really solid workflow. You'll know exactly which file format to use, which database to pick, and the right technique to handle any problem that gets thrown your way.
So we've just walked through the fundamental map that every data scientist uses to navigate their projects. From a single little text file to a massive database, you now